In this video, we'll solve quadratic equations by factoring. So, factoring is very important, so make sure you review factoring and solve as many problems as possible because they do show up in college algebra in different concepts. So, let's do a few quadratic equations using this method. So first of all, it's very important to know that a quadratic equation has the form ax squared plus bx plus c equals 0. A is not 0, and a, b, and c are real numbers. And the very important property that we're going to use to solve quadratic equations by factoring is zero product property, which says if you have a times b equals 0, then a must be 0 or b must be 0. There is no other way. So that tells us that our goal is, from a quadratic equation in this format, to write it as a product of two factors equals 0, so that we can set each of those factors equal to 0. So let's take a look at the first example, which is already solved. It says x plus 4 times x minus 3 equals 0. So if this, it's already in factored form, right? I have a factor of x plus 4 and a factor of x minus 3 equals 0, then each of these factors are going to be 0. So x plus 4 equals 0 means x equals negative 4, or x minus 3 equals 0 is going to produce x equals 3. So in other words, the two solutions are negative 4 and 3. So let's try to do example 2, which says x squared plus x minus 12 equals 0. So I'm working on example 2. Well, it would be nice if we could write it. So our goal is to write it in this format, which means I need to find the factors. So this one, I'm looking for two numbers that have the sum 1. If you remember, the sum is given by the coefficient of x, which in this case is 1, and the product is given by a times c. So in this case, 1 times negative 12, negative 12. The two numbers that satisfy this are 4 and negative 3. 4 times negative 3 is 12, and 4 plus negative 3 is 1. So the factors are x plus 4 times x minus 3. So if you notice, we got the two factors equal 0. We apply zero product property and we get x plus 4 equals 0, which means x equals negative 4, or x minus 3 equals 0, which means x equals 3. So the two solutions that are exactly the ones that we got before. But example 2, it's a little bit different than example 1 because our equation was not in factored form. So our first step is to set our equation equal to 0 and then find the factors. So let's continue with problem 3. 2x squared minus 5x equals 12. So if you remember, our goal is to have factors equal 0. So our equation right now does not equal 0. So first step, subtract 12 from both sides, and we get 2x squared minus 5x minus 12 equals 0. The next step is to find the factors. So we are looking for two numbers that have the sum negative 5 and the product of these two. So the product is negative 24. So the two numbers that satisfy that are negative 8 and 3, right? Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So because the leading coefficient is not 1, what we're going to do is 2x squared minus 8x plus 3x minus 12 equals 0. So basically what we did was rewriting negative 5x using these two numbers, right? If we add them we are going to get negative 5x, but we don't want to do that. Now that we have 4 terms, we are going to group them to be able to factor further. So between the first two, a common factor is 2x, so we get x minus 4. Between the last two, a common factor is 3, so we get x minus 4 equals 0. So now x minus 4, it's a common factor, it's here and here, and then times what is left, it's 2x plus 3 equals 0. So we attained our goal of having two factors equal 0. So what does this mean? It means x minus 4 equals 0, or 2x plus 3 equals 0 based on the zero product property. We add 4 to both sides and we get x equals 4, or we subtract 3 to both sides, so we get 2x equals negative 3, we divide by 2, and we get x equals negative 3 over 2, which gives us two solutions to the quadratic equations. Let's solve example 4. 6x squared plus 9x equals 0. So here I don't have a constant, but there is no problem because the method that I want to use is factoring. And looking at my two terms, I notice that the greatest common factor is 3x. And if we factor it out, we get 2x plus 3 equals 0. So now our two factors are 3x and 2x plus 3. So let's set each of them equal to 0. So we get 3x equals 0, or 2x plus 3 equals 0. This one means if we divide both sides by 3, we get x equals 0. And here, if we subtract 3, we get 2x equals negative 3. If we divide by 2, we get x equals negative 3 over 2. So we got two solutions, x equals 0 and x equals negative 3 over 2. Let's solve example 5. So we have 9x times 4x plus 2 minus 10x equals 8x plus 25. So this equation needs a little bit of simplifying. So first I'm going to open the parentheses by multiplying 9x with each of these terms. So 9x times 4x is 36x squared. 9x times 2 is 18x, so plus 18x, minus 10x equals 8x plus 25. I do have like terms on the left side. So we get 36x squared plus 18x minus 10x, it's 8x, and then 8x plus 25 on this side. So I'm going to subtract 8x from both sides because I want to move everything to the left to set it equal to 0. So we get 36x squared equals 25. I subtract 25 from both sides and we get 36x squared minus 25 equals 0. And we can factor this problem using sum and product, but I also noticed that this looks really similar to a squared minus b squared, which is a minus b times a plus b. So we notice that we actually have 6x everything squared minus 5 everything squared equals 0. So we have a difference of two squares, which can be factored as 6x minus 5 times 6x plus 5 equals 0, which produces 6x minus 5 equals 0, or x equals 5 over 6, or 6x plus 5 equals 0, or which gives us x equals negative 5 over 6. So we got two answers, but we had to simplify our equation first. All right, now let's solve another equation, and this equation it's not quadratic, because if you think about x times x times x, that gives us x to the third, right? But because this equation it's already in factored form, so I have x as a factor, 2x plus 1 as a factor, and x minus 4 as a factor equals 0. So when we have something like this, we can still use the zero product property, which means x equals 0, like the first factor, or 2x plus 1 equals 0, or x minus 4 equals 0. So x equals 0, it's one of the solutions. This one means x equals negative a half, and this one means x equals 4. So we got 3 solutions. So having this problem done here, let's take a look at a problem that is not quadratic, is actually a cube. Minus 5 minus 15 equals 0, and we want to solve it. Well, it's not in factored form, but because I have 4 terms, my thought immediately goes to factoring by grouping. So the common factor between the first two is x squared, and that's x plus 3, minus 5, it's a common factor between the last two, and we get x plus 3. But x plus 3 being a common factor, we have x plus 3 times x squared minus 5 equals 0. So this means x plus 3 equals 0, or x squared minus 5 equals 0. So x equals negative 3, or x squared minus 5. Well, we can factor this again using a squared minus b squared, but in this case we have x to the second minus square root of 5 to the second. So that makes it x minus square root of 5 times x plus square root of 5 equals 0, or x minus square root of 5 equals 0, or x plus square root of 5 equals 0, which means x equals square root of 5, or x equals negative square root of 5. So we got 3 solutions: negative 3, square root of 5, negative square root of 5. I hope this helps.